Hey everyone, welcome back to another DNA Master tutorial. Today we're going to be beginning our annotation. I'll be showing you guys the first steps of what you can do to populate the note sections of each gene, and just a couple things to keep in mind. We're just going to be looking at the start sites, the start codon, the stop site, the stop codon, and the SD score, the gap, and the LO, or the longest open reading frame. That will be covered in this video. I'll show you guys basically how to do it under ideal circumstances and just things to watch out for while you're doing it. So let's begin. We're going to start here on gene 23. Just picked a random gene here, and we're going to you guys should have these notes in the note section or something similar to this, so you can just fill in the little blanks and stuff for each gene. So the first section here is the SSC, or the start stop codons. Here it prompts us for the start site, so all we have to do is look up here. We'll see the 5' end, which is the start site, and it's 19,265. So literally all you're doing is just writing that in here next to the start site here. It may seem a little bit repetitive, but the QC process likes you to do this just in case you change a start site or something like that. You just write it down here just to be sure. The start codon can be found in the sequence tab, so we'll go up here to sequence, and you'll see the first 3 letters of the gene product here is GTG. So what we're going to do is report that here back in the start stop codon place in parentheses next to the start codon. So most of the time it's ATG, that's why I have it there by default, but since it's GTG, all we have to do is remove the A and place it with the G. So now we have the start site, or the start coordinate, and the start codon. We just do the same thing for the stop site now. We look at the 3' end, and it's 19,933, and then likewise we look at sequence, and the last 3 are TAA. So we will report that TAA, and then in the parentheses next to that we put the gene orientation. So if it's in the reverse direction, we would put REV, or if it's a forward gene, we put FWD. By default, the green genes down here are forward genes. On the side here as well, the green ones are forward and the red ones are reverse. So this is a forward gene. We're just going to leave that like that. That's fine how it is. So before we do anything else, we're going to go down here and click post. These will, by clicking post, you will update this note section. It will kind of save it, so to say. It won't save the file, but it will keep track of the changes you just added. So you definitely want to post as often as you can. Every time you populate a section or a category, just hit post. It's always good to do that and get in the habit of doing that. So especially on the next category, we're going to work on SD. If we open up the frames thing that we'll need to get the SD score without posting, it's going to get rid of the change that you just added, which is a little bit annoying sometimes. So definitely post. Alright, so now that we posted, we're going to fill out the SD section. The SD is the Shine-Dallarno score, and that can be found if you go up to DNA at the top here and then hit frames, and a window will pop up here in just a second. I showed you guys this in previous tutorials, but this is always good to review. Here it is. We're going to hit the ORFS, or the Open Reading Frames button here, to show all of the open reading frames, or where the genes are on this 6-frame translation. And we're going to go down to the gene that we're working on. So since we're working on gene 23, we're going to find it over here. Maybe we'll scroll over just a tad. Gene 23, we're going to click it, and you'll see a little green bar kind of above that little area. So once that's there, you'll see the RBS button. You'll click the RBS button, and it will generate this nice little graph, or excuse me, this chart here for you. Once you have the chart, you can head back to the notes, and you're going to look at your start site here, which is 19,265, and what you're going to do is find it over here. It's actually the first one on the list here. That's what will happen most of the time, but sometimes you'll have to kind of search further down the list. So just look for your start site, 19,265. It's right here. Just to check, we have our start codon GTG. We already reported that. And what we're looking for here is a final score. This is what we're going to put in the SD section. So it's always negative, but the closer it is to 0, the better the score is. So as you'll see here, the one below it is negative 5.606. That's farther from 0 than negative 3.9 is. So this would actually be a worse score, which is even more proof or evidence that this is truly the start site to the gene. So that's just a little more evidence, and it doesn't totally 100% mean it, but it's looking like this is truly the start site, because first off, we had Glimmer and GeneMark agree that this was the start site, and that's shown up here. By the way, if there's only one name here or one call, that means they all agreed on that. So that's our first piece of evidence that that's the start site. And again, this is a better SD score, a much better SD score than this is. So what we're going to do is report that score here, negative 3.926. And now after that, we have to look through this list to see if negative 3.926 is the best score or not. So like I said, the closer you are to 0, the better. And if we go down the list a little bit, we'll see this here. Number 4, negative 3.502. That's actually closer to 0 than this was. So unfortunately, it's not the best score, but that's not really a big deal. Since it's not the best score, we'll just report over here. We'll just add not best score. And then once again, we'll post, and then we can get rid of that. And that's it for the SD score. So for SES, all we have to do is look up into the first line of the note sections. You don't want to delete this code. It's going to be, or this sentence, it's going to be automatically generated by the program when you run auto annotate, and it will stay in the program. It's very useful, and the QC process will need it, so don't get rid of it. But all you have to do is, if you see only one call here, you'll only see one start site call, you would just type in agrees with GeneMark and Glimmer, because if there's only one call here, like I said, that means that GeneMark and Glimmer both agreed on this start site right here. I can show you guys an example of when they do not agree, which is right here. You'll see Glimmer called it at this one, but GeneMark called it at this one. So these two would disagree, and for that SCS category, we would just say agrees with, let's say we're going with the Glimmer call, we would just say agrees with Glimmer. But going back to our gene, since they both agree, we can just leave it as agrees with GeneMark and Glimmer. We're going to skip over CP, or coding potential, for this episode, and we're going to go to gap. The gap is simply calculated from looking at the start site of your gene that you're working on and subtracting it from the stop site of the previous gene. So if we look at where the previous gene ends, 19,264, and where this one ends, 19,265, we'll see that there's actually a 1 base pair gap in between. So all we would have to do is report a gap, 1 base pair gap from end of previous gene, and that's all we have to do for that. If there's an overlap, you would simply write overlap instead of gap. And lastly, LO, or the longest open reading frame. All we have to do for this is go back to our frames table. So we're going to post the changes. We're going to hit DNA frames. We're going to hit ORFs, select our desired gene, and hit the RBS button. So now what we're looking for is, once we found the start site up here again, we're number 1 on this chart, we're going to look to see if this open reading frame is the longest. And if you're number 1 at the top, it's going to be the longest, because this is actually sorted by open reading frame length. So this is the longest open reading frame, and in this case that happens to be our start site. So yes, this is the longest open reading frame. So all we would have to do is go back into the notes section, LO, we would say yes, this is the longest open reading frame. Say if, for example, if this was our start site, it's clearly not the longest open reading frame, because there's open reading frames that are longer than it. So we would just change it to no, and then all we'd have to do is put the base pair, or this number, which is the length of the gene. But since this is the longest, we're going to leave it at yes, and we're going to insert the base pair length, or the open reading frame length, which is 669 base pairs. So that's all we're going to do here, 669, and hit post. And that's pretty much it for this episode, guys. That will get you started on each gene. If you want to go ahead and do that right now before watching the next episode of all your genes, that may be good. But if you want to learn how to fully annotate one gene, catch me in the next tutorial, and you guys will continue with that. So thanks for watching, guys. Hope you learned something new. If you have any questions, as always, let me know in the comments. I'll be sure to answer them. Have a good day, guys. See you later.